Okay, Mock Set 10, Paper 2, higher tier, walkthrough. Let's go. No messing about. Right, number 1A, typing it into your calculator. Uh, yeah, if you're not getting this one right, you shouldn't be doing the higher. Either that or your calculator. If you haven't got a scientific calculator, what you're doing, buy one immediately because without one, it's going to be so much harder and not recommended. So anyway, look, type that in. I get 4.0. Let me just get my pen up. 4.0591469194. Now, in the Mott scheme, you only have to get up to 5.9. So don't. The Mott scheme is basically anyone, because obviously different models with calculator will give different digits. As long as you're writing 4.059, that's enough to get marks. But obviously, the more the merrier in this case, right? And round into two decimal places will be 4.10. Bit tricky one, this one, because obviously, did I just say 10? I take that back. That would have been to one decimal place. To 2dp would be 4.06. My bad. I thought one decimal place. I don't know what I was thinking there. 4.06 is right. Cool. Number 2. Freaks Polygon. Two things they've done wrong. They've joined the first and last point. Classic mistake. Joined the first and last point. Yeah, I know the word polygon is usually a closed shape, but frequency polygons are slightly different in the sense that the first and last point should not be joined together, and ironically doesn't make a polygon in the sense of it is a closed shape. It's more of a sort of line, if you will. But that is one mistake they've made there. And another mistake they made is they should have chosen the midpoint. So they chose the end point. That's only something you should do. No, they chose the midpoints for all bar the first one. So they actually kind of did most of the points right, except for the first point should be plotted. The first point has been plotted wrong. So let's be a bit more technical here, because they may not know what you mean. So actually, I would improve the second bullet point. I'm going to take this back. I'm just looking at the mark scheme, and you want to be extra safe. It's vague as to what you mean as the first point, so we'll just specifically say the point at, and then we'll highlight 10.2 should have been plotted at 5.2. Okay, so then there can be no shadow of a doubt that we meant that this point here. Yeah? Cool. Number 3, Kate swims. Okay, so this is classic speed distance time, isn't it? And it wants the total time. So Kate swims 1.5 kilometers, speed of 3 kilometers per hour. So Kate swimming. So for the swimming part of her journey, the speed is 3, distance is 1.5. I'm not going to bother with units here. So time, which you should remember is distance over speed, would have been so 30 minutes, right? Or half an hour. So yeah, 1.5. You don't even need a calculator here. 0.5, unit being hour, right? So half an hour or 30 minutes. So that's for the swimming part. The other part is obviously the bit where she runs. So again, her speed is 8, her distance is 10, so her time, distance over speed, I'm not going to write the formula out again, 10 over 8, which will be 1.25. I didn't even need a calculator for this. I will type it in though. I don't want to leave anything to chance. Yeah, 1.25 is right. So her total time will be the 0.5 from here plus the 1.25 here, which will be 1.75 hours. So it'll be 1 whole hour plus this 0.75 of an hour. 0.75 being 3/4, meaning it's 45 minutes, isn't it? So because the 0.75 of an hour, if you think about it, 75% or what, 3/4 of an hour, you should already know is 45 minutes. And again, if you didn't know that, you could have multiplied it by 60, all good. So it should be 1 hour, 45 minutes. VAR check on the mark scheme agrees. Okay, right. This means it will take less time. Answer to A will be lower. Okay. Yeah, I mean, if you go faster, it's going to take less time, surely, if the distance, we assume, remains fixed. Number 4, we've got green, purple, and orange beads. And, okay, so we call this connected ratios. So the first line gives me the ratio of green to purple is 4:3. And the second one, actually, I'll represent this with green, so I'll rub this bit out here. But it tells me purple to orange beads is 5:6. So when we connect these ratios together, I want to write this as a single ratio. So I want to go green to purple to orange. So the number that's going to connect them both is clearly the purple amount. And I need to think, right, what's the lowest common multiple of 3 and 5, right? Well, that's 15, right? 15 is in both of these times tables. So that means that I would have had to multiply this first one by 5. So this first number, the green, would have been 20. And the second one was multiplied by 3. So the number of orange would be 18. So if I want to connect all 3 numbers together, now, because the number of purple is 15, I know what numbers to put for green and orange. It is 20 and 18, respectively. Nice. So we're sort of on the final stretch now. There are 54 orange beads in the bag. So looking at my new ratio, if there are 54 beads in the bag, well, let me do 54 divided by 18. 3. Basically, what I've got to do now is multiply all the numbers by 3. Okay, and we'll get the number of purple and green. So 45 for purple, 60 for green. Don't even need a calculator for this one. I don't even think the total number of beads, right? So total number would be just these numbers added together. It's going to be like 150, 160 something. Let me just type this in real quick. And I'm getting 159. And does the Mock scheme agree? Yes, it totally does. Good stuff. Yeah, that's called connected ratio. 159. Let's write that in the answer line. Bam, bam, bam. Love it. Next up, we got number 5, Ahmed. Bias dice. This means it's not fair. And the probability it lands on 4 is 2/3, meaning that the probability it doesn't land on that will be 1 minus, it'll be 1/3. So remember, each of these branches, whatever they have to add up to 1 whenever they branch off. So this would be 1/3 as well. This would be 2/3, and this would be 1/3. Okay, very good. Could have probably done this a bit more clearly. Okay, so the probability he lands on 4 twice. Again, think of this as, here is your starting point. Which route would you have to go along to get 4 twice? You'd have to go this way first, this way second, multiply the probabilities on the way to the end. So it'd be 2/3 times 2/3, which is 4/9. You don't even need a calculator here. Easy money. Was that it? Wow, that's pretty easy. Number 6, we've got shape, all dimensions in centimeters, right? So they're not bothering with units. Perimeter 78. Okay, so let's work out some missing sides first. This side and this side, I have to add up to this side on the left. So if this side's 2x, I'll need to add another 4x onto it to get a total of 6x. So that's my first missing side. So I've got 4x and 2x, yeah? And of course, if this is 5, 5 plus some number equals 21. Right, those two lines above are exactly the same length as the bigger line underneath. So that would be 16. So, okay, so I now know all of the missing sides of this shape. So perimeter will be all of these added together. So it'll be, let's just start A, work my way around. So it'll be 6x to begin with, plus this length here, plus 21, plus your 2x, plus your 16, plus your 4x, and finishing up with the 5 to return me back to the beginning. Now, we know that all of these added together would give me 78. So you know what? I can replace P because it literally tells me it's 78. So let's do that. And to tidy things up, let's have all the like terms together. So 6, 2, and 4, that's 12x. And your numbers, 21, 16, and 5. So we've got 21, 16, and 5. Give you 42. So now we solve this equation, right? We solve it by taking away 42, left and right. So this would be 36 is 12x, meaning x is 3. Now, don't get overconfident here. Always, when you find x, reread the question. Did we answer it? Let's read it once more. Was it about finding x? The question says, the perimeter of the shape 78, work out the area of the shape. Have we worked out the area of shape? No, we've only worked out x. So, again, this is important. We do need to know x, but it is not the area. The area is the area of two rectangles, right? So what we do here is, and we call this partitioning, is we can split this L shape into two rectangles. Now, purple rectangle, the area of shape. Since we now know x is 3, the height of this rectangle is 6, but the width is 21. So the purple rectangle is going to be 21 times 6, which is, in my calculator, 126 centimeters squared. And we'll do something similar now for the rectangle on top. So this one here, be really careful. The width is 5, but the height is 4 lots of x. So 4 lots of 3, 12. So again, that's going to be 5 times 12, which is 60. And to wrap things up, we will need to add both of these lengths together. So we've got 126 plus 60 is going to be 186 centimeters squared. 186. Give me a bar check, please. Did we get it right? Absolutely. Good. Yeah, a lot of people are going to get really, really happy with themselves because I think finding x is probably the harder part. But do make sure you are answering the question there because I bet a lot of people sort of stop at x and not actually read what they need to find. That's why we always say as teachers, reread the question. Okay, right, power. So when we multiply powers with the same base, we add the indices. So this will be the same as 5 to the power of 9 plus 6 take away 4, which 9 plus 6 take away 4 is 5 to the 11. And that's 5 to the m. So these powers are the same. M is 11. Oh no, sorry, it doesn't want to know what m is. It just wants you to write. It's just saying, look, it just wants you to write it as one single power of m. So it's 5 to the 11. Now, interestingly, I know the relationship between 1 and 49, is that's 7 squared. And I also know that 1 You can rewrite any 1 over sort of questions as literally the bottom number. If you put a little minus sign there, that's how we do it. So it's 7 to the negative 2. Okay. And that's the answer to B. C, we're going to write this in order of size. So this is an interesting question. So before I get into things, standard form. X squared will be 2 times 10 to the 100 times 2 times 10 to the 100. So x will be 4 times 10. Remember, you add the powers of to the 200. Again, you could type this in a calculator, but whatever. So that's x squared. Sorry, I should have mentioned that. Now, the tricky one is going to be 1 over y. So 1 over y will be 1 over 3 times 10 to the minus 100. Now, interestingly, this will be the same as 1/3 times 1 over 10 to the minus 100, which is 1/3 times 10 to the minus 100. And funnily enough, this 1/3 stays put, but that bit at the end there will be 10 to the positive 100. So that's actually going to be quite a big number. Now, I know what you might be thinking. Oh, that's not in standard form because the first number should be bigger than 1. But this question doesn't want us to write anything in standard form. So you know what? I'm going to leave it like that for now. Yeah? Just remember that 1 over y is this. Yeah? We don't need to write... I know you can all write the standard form if you wanted to, but this is a comparison question. So, let's think about what we've found. Now, of all three numbers, y on its own is literally the only number with a negative power of 10. So for that reason, we will start with y is the smallest number. Secondly, the next number along, clearly x squared is the biggest, right? Because this is sort of 10 to the power of 200. It's going to have, like, roughly speaking, an extra 100 zeros on 1 over y and x. Fair enough. So we'll leave x squared last. Obviously, now the tricky part will be comparing which between x and y is bigger. Well, remember, x we said was 2 times 10 to the 100. So when we compare numbers in standard form, we always look at the power first, and if they're the same, which in this case they are, we then have to say which of the sort of number at the beginning is smaller. And clearly, 1/3 is smaller than 2, so 1 over y is the smaller one between 1 over y and x. So this is the correct order. Well done if you said that. So let's move on. Number 8, Andy. Ooh, okay. So Andy's investing some money, and he's getting compound interest. And we've got two banks for comparison. We've got PB, which obviously stands for People's Bank, and Good Rate Bank, GRB. So, which is going to give Andy the most interest? Well, let's think. People's Bank, they're both compound interest. So, the first bank account will take us £20,000, and the multiplier for 3% will be 1.03. And because he's investing it for 3 years, we'll raise that to the third power. So if he puts his money in People's Bank and he waits 3 years, at the end of the year, once he looks at his bank balance, he should have £21,854 and 54 pence. No rounded necessary there. So he's got, roughly speaking, about £1,854.54. Fair enough. For good rate bank, you'll notice in the first year he earns more, but in the sort of last 2 years he earns a slightly less percent interest. So which one gives a better value overall? Well, think of it this way. We would multiply this by, well, for the first year, the multiplier for 4.4% would be 1.044, but then we'd multiply that answer by a 2% increase, 1.022. But obviously, it'd be not just the second year, but it'd be the third year as well. So you can write it as I've done, or you could have written 1.022 squared. But either way, I don't think there's, effort-wise, they're comparable, aren't they? So probably the power will be slightly quicker, but you're not losing marks, are you really? So if you go for GRB, good rate bank, you would get £21,000, 808.8. I'm going to round up 83 pence. So which bank? This is an interesting question. So we'd say good rate bank pays more interest. Oh, I can't believe I said that. That was a lie. Why did I think that was a bigger number? Clearly, PB is the higher of the two numbers. What's come over me? Right, People's Bank pays more interest. I would have lost 1 mark for that wrong conclusion. But yeah, you get 1 mark there, 1 mark there, 1/3 mark for getting two comparable figures, and obviously the 4th mark for the correct conclusion. You don't qualify for the conclusion unless you've earned the first 3 marks, just so you know. Number 9. All right, so we've got cumulative frequency graph running total. So first one's 8. Second one, you have to add 8 and 21, which is 29. Then to get the next one, we add 27. So the hack is to do 29 plus 27, which is 56. Basically, you just add the number below. So plus 15 now, you would get 71. Plus 6 is 77. And wrapping up by adding 3 at the end, you get 80 last. Okay. So it wants a cumulative frequency graph. Remember, don't ever do the midpoint on a cumulative frequency. It's always the number on the right. That's your x coordinate, and this is your y coordinate. So let's go ahead and do that. 20 with 8 first, which is roughly speaking there. Do the next one. We've got 29 and 56. 29 and 56, which is roughly speaking 71 and 77. And 80 last. Okay. And then what we do is we join all of these with a smooth curve. This is all free-handed. Please do not use a ruler. It can wobble slightly, but it must go through the crosses. So that part has to be accurate. Again, the examiner will leave you half a square max when it comes to crossing the x's that you've plotted. So you must be accurate. Okay, so let's have a look. That's part B done. Use your graph to find the estimate for the percentage of people who are less than 25 years old. So if I look at 25 years old and I read across, I read 16. So there are 16 people out of 80. Remember, we want to make that percentage. So 16 people are less out of 80, obviously, which is what, 20%? I think the mark scheme will agree, but I will get a VAR check. Yeah, it allows 20 to 24. Again, because people's lines will wobble, they'll sort of allow you anywhere within that range. Interquartile range, right? So remember, median is half our people. So if you're asked for the median, you'd go across and down, like I'm doing right now. Median splits your data in half. Yeah? think of it as this. If you ask, you know, if you line all 80 people up, the median person would be what, 33 roughly years old. Quartiles do the same thing, but you break it into quarters. So you divide the total number by 4. So in this case, 80 divided by 4 is 20. We are interested in going up in 20s because you'll notice it splits your data into 1, 2, 3, and 4 sort of equal groups. So it's kind of like you're saying, oh, all 80 of you, I want you all split up in sort of groups, in 4 separate groups. And, we want these 3 people. These are sort of like the 3 people who define where each of the 4 groups starts. That's a way of thinking of quartiles. Technically speaking, the second quartile is the median. We rarely use that word, but you're with me. Now, IQR, interquartile range, is found kind of like, with range, you take away the biggest, take away the smallest. IQR is you take away your biggest quartile. In this case, it's the upper quartile. Take away your lower quartile. So looking back at my list, the upper quartile is this. So we're going to go across and down at 60, which I believe, again, I'd recommend strongly using a ruler here, but of course on an iPad, it's not very good. So yeah, look, I'm getting 42 as my upper quartile. Subtract from that my lower quartile, which is found at 20. So same thing, I would use a ruler here in normal circumstances, and I'm getting 27. So 42 take away 27 is, you know what, I could do that, but I'm going to be lazy and use my calculator. 15. Okay. Mark scheme allows, let me read it. It will be quite generous here. It says 14 to 17. So, yeah, be accurate. But yeah, anything between 14 and 17, obviously I'm totally fine here, would be accepted. All right, we're doing quickly today. What we got now? We got a hemisphere placed on top of a cylinder, and we are given the radius of the hemisphere and the radius of the cylinder. Yeah, they're both the same. Okay, interesting. All right, let's start by finding the volume. You'll notice this is a volume of sphere. The volume of a hemisphere is basically half that, right? It's kind of like chopping your sphere in half, which half of 4/3 is literally 2/3. So let's use that formula and let's work out the volume of the hemisphere, which would be 2/3 times pi times 6 squared. We'll try and keep it in terms of pi, which would be 2/3 of 6 squared. That'd be 24 pi, right? So we've started by finding the volume of the hemisphere, 24 pi. So the volume of cylinder will be obviously this. This is the whole shape, but obviously we've now found this hemisphere volume, so we'll take away the 24 pi. So it'll be what, 516 pi, I believe? 516 pi. Do you know what? Let's leave nothing to chance. Yeah, it's 516 pi. So that's the volume of the cylinder. Now, if you've forgotten the volume of a cylinder, you can rely on volume of any prism. So you remember the volume of any prism, and this includes cylinders because cylinders is a special case of prism, is you work out the area of the cross-section, the area of cross-sectional area, times your length. Now, the area of the cross-section is a circle, isn't it? So that would be pi r squared. And then obviously your length is your height in this case, right? It's usually the distance between the two cross-sections. In this case, we'll call that length height. So pi r squared, the radius is still 6 squared, so we've got pi times 6 squared times h equals 516 pi. Okay, so good news for us is the pi's cancel out. So 36h is 516, so the height must be 516 divided by 36, which, using my calculator, will be, I'm getting 43/3. Is that right? No, it is not. I made a mistake somewhere, clearly, which is not nice. I do not like making mistakes. Where did I go wrong? Let me identify my mistake. So, uh, so 24 pi is spot on. The volume of the solid. So 540 take away 516. Ah, I'm such a. No. I can't believe I did this. I misread the. You probably picked up on this earlier than me anyway. All right. I'm having a mare of a day, people. So, in this particular question, you'll notice, and I should know this really because I rarely use the volume of a sphere, it's pi r cubed. What made me say pi squared, I do not know. But let's go back. So, the whole method was right. It broke apart because I blimmin' squared the 6 instead of cubing it. Would you believe it? So, if you cubed it, you are smart. So, it should be 144 pi. So forget what I said earlier. The volume of a cylinder is 540 pi. Take away 144 pi. Not 24. Can't believe I did that. So that's actually 396 pi for the volume of cylinder. So the volume of prism is still pi r squared times h. Obviously, radius being 6. And we'll times that by h, our unknown. And that will be equal to this 396 pi. So the pi's now cancel out. 36h equals 396. So divide that by 396 divided by 36, which gives me hopefully something a lot nicer. 11. So height is 11 centimeters. Always reread the question. Okay. If you got this far, well done. But wait, you are not finished. Why, you might ask? Because what does the question ask for? It wants the height of the solid. Not the height of the cylinder, but it wants the height of the solid. So what have we just shown? We've just shown that this height, which I'll do in purple, is 11. But that's not the whole height, is it? There's more to this story. Well, yeah. I mean, look, the radius is 6. So we could actually prop that radius 6 as well. The height of a solid, maybe I should have probably chosen a different letter for the height of the cylinder, of the solid will be your 11. That's the height of the cylinder plus your 6, which is the radius. So the total height will be 17 centimeters. Well done if you got that. Factorize. Okay, we love these questions. Now, if you're really confident with the trial and improvement method, fair enough. I like the old school AC method. Teachers love it. Teachers hate it. But it works it's a one-size-fits-all method. It may not be the quickest, but it gets the job done. So AC, in this question, A is the number in front of x squared, the x squared coefficient, that's 6. And C is the number including the sign at the end. So that's -7, and that gives me minus or -42. B is the number in front of the x coefficient. And basically, we're after two numbers that add to give 11, but multiply to give -42. So this is a bit of a tricky one because in my head, I always like to think of, right, what pair of numbers do I know multiply to give 42? Ignoring the sign, well, 6 times 7 is the most common, But unfortunately, it's impossible to get 11 from these two numbers. So let's try something else. Let's try 3 and 14. So, yeah, this is not, 3 and 14, yes, they are multiplying to 42. And you can make 11 by making the 3 negative and the 14 positive. So there we go, we've found our two numbers. So the AC method works like this. Once you find those two numbers, that's how you're going to split your middle x term. So the 11x becomes, in either order, I always like to go with actually I don't really have a go-to, I just write one number in front of the other, so minus 3x. It doesn't matter which of these two you put first. And this kind of makes sense, right? Because you can split 11x into 14 take away 3. There is nothing wrong with doing that. So here's what we do. Once you've done that, you factorize the first pair. So you'll notice both of these two terms have a common factor of 3, but also the letter x as well. And inside my brackets, I would need to put 2x minus 1. Fair enough. And I'm going to do the same for this pair. They're both, the common factor here would be 7. So we'll write a plus 7 because they're both 14 and 7 are in the 7 times tables. 2x minus 1. Again, at this point, you should notice that your brackets have the same thing. If not, obviously go back and correct whatever mistake you've made. And the thing that goes in the first bracket are your numbers in front of your two brackets above. So it'd be 3x plus 7 in brackets there. Okay? So that's our answer. So it'll be, in either order really, 3x plus 7 in one bracket and 2x minus 1 in the other. You can write 2x minus 1 first and 3x plus 7 second, but do not mix up the minus and plus. That bit is important. So x is directly proportional to y cubed. So that's my argument proportion. Oh my god. Why am I mixing up my squares and my cubes today? I do not know. Right, so there we go. So anytime we have a argument of proportionality, there is an equation that can be written. And there's usually a constant proportionality that you must put in there somewhere. So I'm going to write x equals ky cubed. And I can work out that value k by substituting these two numbers in for x and y respectively. So when x is 850, y is 5 squared, well, y is 5. So the relationship, if I want to work out k, I'm going to do 850 divided by 5 squared, which, again, the benefit of this now is your value k never changes. So you get 34, right? So you can update your equation. Instead of writing x equals ky, you can now say, well, look, I know that the number relating x and y squared together is none other than 35. So x is always equal to 35 lots of y squared. So to wrap things up, to finish the question, we're going to substitute y is 4, into this equation. So we're going to get 35 lots of 4 squared, which is 35 times 4 squared, 560. That should be right. Let me give it a quick look on my mark scheme. Five, four, what? Now this, why did I write 30? Oh, how is my calculator giving me 34? 35, sorry, it's 34. What on earth is going on there? I'm having a nightmare. 34. 34. I can't believe this. 544. Good stuff. I don't know what's going on with me there. Yeah. Why did I write 35? Interesting. Anyway, we move. So I would have lost probably 2 marks so far, maybe 3. Right, make R the subject. So this is a tricky one because in this question, the letter R appears twice. So in my answer, making R the subject means we write R equals ... That's the only R that we're going to see in my answer. So I'm going to show you how exactly we can go from having two R's to simply one if you follow these simple steps. Okay, so step one. Let's get rid of that fraction. How, you ask? We're going to multiply both sides of the equations by the denominator. So usually when the denominator has an element of adding and subtracting, we will need to use the brackets here. So we're not just multiplying by R, we're not just multiplying by -3, we're multiplying by both R, take away 3. So using brackets, I'll have T bracket R, take away 3 equals, well, look, on the right-hand side, I'm multiplying by the same as the denominator, so you can say they cancel out. My first step is by writing T bracket 3 minus R equals R. I've multiplied across that denominator, basically. Next, what do? I'm multiplying out this bracket. So T multiplied by R is TR, and T multiplied by -3 minus 3T equals the letter R. Now remember, we want to make R the subject. So what I'm going to do is I'm going to move everything with R to one side and everything without to the other. What does that mean? Well, what I'm going to do first is I'm going to move everything with an R to the left. We've got 1, 2, 3 terms. So you know what? I've noticed this middle term doesn't have an R. So I'll be moving it to the right-hand side. And when I move it to the right-hand side, it will become positive. So usually I'd do this all in one go, but I really want you to follow my steps here. So all I've done is I moved it across. It's now plus 3t. But obviously I want to move this R to the left-hand side. So it will be take away R. Yeah, so it goes from being positive, if you move it across, it becomes negative, equals 3t. The bit on the right stays put. Now, how do I go from having two R's here to just one? Well, you factorize, right? Both of these terms have an R in them, so we'll factorize out the R, and in brackets, we would put a t minus 1. Okay, so why is factorizing so important here? Well, look, notice how we've gone from having two R's in the line above to now simply one. The trick is factorizing. Yeah, that helps you sort of remove the fact that you saw two R's and now only one. And the final step is we want to do the opposite of multiplying by the bracket t minus 1. We, in fact, divide, don't we? So to finish this question, it'll be 3 brackets t minus 1. You can include brackets there, but because it's the only thing on the denominator, that is not necessary. So, you know what? The answer is 3t over t minus 1, with or without brackets. Up to you. I think I've already made like 2 mistakes this exam, so I can't really afford another one. And I can tell you now that the mark scheme is spot on. Okay, right, so this is limits of accuracy. Now, to 3SF. So if we look at my number, you've got ones, tenths, hundredths. So usually the way that, all I'm going to do first is I just want to know what the upper and lower bounds are for those 3 letters. So the way that this works is as follows. If you want to know the upper bound, look at this. 3SF means we're rounding to the nearest. This has been rounded to the nearest 100th. Yeah, or you can say to the nearest 0.01. What the trick is, you always halve what it's been rounded to, which will give you 0.05. You basically add and subtract that on to 8.92. So the upper bound would be 8.92 plus this number. So the upper bound would be 8.925. And the lower bound, we would subtract that from 8.92. So it'd be 8.915. Yeah? Now, the second number u is actually quite similar here. So I'm not going to explain this, but I will say that the upper bound is 5.345 and the lower bound will be 5.335. And the last one only has been rounded to 2SF. So this has been rounded to the nearest tenth, 0.1. Halve that, obviously, you get 0.05. So we'll add and subtract that to 1.2 to get the upper bound is 1.25 and lower bound is 1.15. Okay, so before we even read further into this question, I've just said, I know its bounds basically, the value b at its highest could be as big as this. We don't know because it's been rounded, and vice versa, right? The value of v could have been this as its smallest. So it wants the lower bound of a. So a, when it says lower bound, you are allowed to mix and match whatever number you want for v, as long as it's between these two regions. The same for u and the same for t, right? We're allowed to pick any number within that inequality for v, u, and t. But the objective is we want the smallest possible value of a. So look, we want the lower bound, right? So we'll say subscript LB. It means I want the lower bound of a. I want the smallest possible answer of a. How am I going to do that? Well, so let's think about it logically. If I want the smallest number, starting with the positive, I want the smallest possible value of v. Yeah, I want to choose this number. Yeah, I want the smallest possible value there. Take away. Well, if you're taking away, you actually want the biggest number. In order for a to be at its smallest, you want to take away the more you take away, the smaller your number, right? So we want to take away the biggest possible value of u. So we will be subtracting 5.345. If we were to choose 5.335, our answer would not be as small. So no. And what number to divide this by? Well, what do you know about division? The bigger the number you divide by, the smaller your answer. So we will also be choosing this number deliberately to divide by, right? If you divide by 1.25, your answer will be smaller than if you were to divide by 1.15. So doing all of this work, let's see what you get. So 8.915. 8.915. Take away 5.345 all over 1.25. And I'm getting a fraction here, 357 over 125. But it wants, is it given to me? Let me check the mark scheme. I'll write the decimal number 2. It's actually not that long, 2.856. The mark scheme sort of allows 2.856 to 2.86. I think it just assumes you might have rounded to 2 decimal places because, and I think the reason they've done this is these two numbers, these first two numbers were rounded to 3SF, so they allow students to do that. Fair enough. Right, so either that or that would be fine. Okay, so I'll give this a little bit of context here, right? This, if I move the 7 over, solving this equation would be the same as solving this, right? All I've done is I moved 7 over. Now, if you were to sort of sketch a cubic graph, it would look roughly like this, right? Now, what it's saying is there's a solution between 1 and, let's say for argument's sake, 2, right? So imagine that is a positive number and this is a negative number here. You can prove there's a solution if the sign changes, right? So if your graph goes from being positive to negative, it means that the line crosses at some point, right? Between 1 and 2. So that's all we got to do. So we will be substituting x into this, and I'm hoping for one positive and one negative solution. It doesn't really matter which one's which. But if we do that, we win. So let's substitute. We'll start with the easy one now. X's one should be easier. So we'll get 1 cubed plus 4 lots of 1 squared. Take away 6 lots of 1. Take away 7. And calculating this gives me, it's going to be a negative, isn't it? So 5 take away 13, which is -8. Okay. And now we will be substituting x's too. Slightly more challenging. Well, not really by much, but I'm hoping for a positive number now. Otherwise, I'll be a little bit worried. So let's be a little bit careful here. This actually comes up on A level. Funnily enough, so you got 8, 16, 12, take away 7. 8 and 16 is 24, take away 12, take away 7 is 24, take away 12 is 12, 12 take away 7 is 5. So you can then deduce there must be a solution since there is a change of sign. Yeah, that's how we do it. Let's see how the mark scheme handled it. Yeah, they got -8 and 5 also, so yeah, very good. Okay, so 15b, funnily enough, is a harder version of 13. So let's see how you fare. Okay. Oh, wait, no. No, forget it. It's not a harder version of that. At least I don't think so. Okay, so all this iterative formula means is to find the next number along. So x1. Well, clearly, if I use x1, that means n is 0 in this case, because 0 plus 1 is 1. So I do the square root of 6, lots of x0 plus 7 over x0 plus 4. I'm going to show you a little hack. Yeah? Here's a little hack for you, right? In your calculators, just type in 1.75. Yeah? Just bear with me. Let me land. So literally write 1.75 equals. Now, when you press equals, you have now stored that as your answer. So here's what you need to do. You're going to do x1 equals, and then this is what you're going to type in. I'm not going to write this, right? This is more of a side note for you. But so you are going to write into your calc, you're going to write the square root of 6 and then ans, which should be in your scientific calculator, plus 7 over ans plus 4. Now, why? And you have, before you do any of that, make sure you write 1.75 equals into your calculator to get that stored as your answer. So be really, really careful here. Do the formula correctly. So 6 ans plus 7 over ans plus 4. And it helps you, right? So x1 will be 1.7445. Now, the beauty behind all of this is if you press answer again, it'll work the next number out. So look, it will now say 1.74375 ... And if you press x again, it will give you x3, 1.74363. So it wanted you to do it 3 times. Okay, so yeah, to 4 decimal places. This is the one it wants, isn't it? Because you've used it once, twice, 3 times. You could go more, but I think because it wants you to only use it 4 times, 3 times. Don't go further than this, yeah? It would be mean for them to take away marks for you to go slightly further than this, but again, you want to play by the rules they set. So let's just write down the 3rd iteration. So yeah, because you want the examiner to know, you're letting them know that you understand when to stop. 1.7436. to 4 dp. Okay. Let me check my independent adjudicator. Yep, it's happy. Good. All right, so look. So all right, so this one's transformation of graphs. So you've got f of x is sine x. So 2fx would be 2 sine x. Interesting. No, this is not that. This is not that sort of question. My bad, people. My bad. My bad. Yeah, because I'm looking at the graph. There's 2 ways we could have really solved it. I think that would not be practical. So the way it wants you to solve it is just by dividing by 2. So I've divided both sides of my equation by 2. Yeah, it's going to be a whole lot easier than thinking about transformation of graphs. Basically, you're saying when is sine x is minus a half. So let's find minus a half on my axes. Go across with a ruler. Obviously, I'm on an iPad. And I'm going to get this as one of my 2 values. And the next number along would be this number here. So each 5 blocks represents 30 degrees. So that'd be 210 and 330. So your values of x are 210, 330. You don't believe me? If you type 2 times sine 210, you will get minus 1. So if you don't believe me, sub either of those in. I don't even have to check the mark scheme here. I'm happy with that. Again, this is only a 2 marker, so they're really, yeah, I don't think there's really much more work you need to do than that. Right, this is what I'm talking about. Right, so you want to draw this graph. Let's remember what this means. So remember, your x's always lie to you. You would usually think of the brackets as left or right, but counterintuitively, -1 actually means you go right once, right? So we're going to start by just moving this graph 1 unit to the left. So this would go here, this would go here, this would go here, and so on, right? So the whole graph, again, if you've got tracing paper, you can sort of trace the original graph, shift it 1 unit to the right. I'll do my best. But yeah, the way this works, because there is a combination, isn't there? So we'll move that to the right first. So it's going to look like this. But the +2 means we move it 2 up. So 2 up. So this point now goes here, this point goes here, this point goes here, this point goes here. And then look, here is your finished product. So we've got f of x minus 1, because it's shifted 1 unit to the right, and 2 up. Okay, so we've done that. For the sake of the examiner not confusing your work, I probably would... I definitely would write the purple line I drew, but make it so... Make sure you label it though, so because what you don't want is the examiner thinking that you're giving a choice of answers. So make it clear to the examiner that this is only f of x minus 1, and then the +2 comes from moving it up 2 units. Yeah, so make sure you're labeling it, because if you don't label it, the examiner may confuse that with a choice of methods, and you'd probably only get 1 of 2 marks. Okay, so 0.57 lies on the graph y is gx. Okay, right, so remember, g of x basically reflects your graph in your x-axis. So, like, just to give you an idea, if I wanted to do f of minus fx of the original graph, it would look like this. All the x-coordinates would remain identical, but all your y-coordinates would be turned into a negative. So 5, 7 would become, well, x remains unaffected, but your y-coordinates all get negated. So -7 would be the correct coordinates. I think I've got time for one more. I say that. This video doesn't really make sense when I say that, because it will just cut to the next scene. But I'm going to probably take a rest. I know that it's kind of not fair, because we're meant to do this all in one sitting, but hey. All right. All right, this is a pyramid. And it's got triangular base. ADB. All right, so okay. Some naughty question here. Calculate the length of AB. Okay. So with this question, you've got to use your imagination a little bit. But right there, we are staring at a right-angled triangle. What do we know about right-angled triangles? We know Pythagoras' theorem. So this length here, which we'll call BD, is the square root of 15 squared plus 5 squared. So 15 squared plus 5 squared is 250. So BD is the root of 250. I shall leave it as a third. I don't think that simplifies nicely. Or 5 root 10. Do you know what? I'm going to leave it as root 250. It's easier to work with. So this length here, root 250. Okay. And similarly, again, I'll do this one in purple. This is also a right-angled triangle. Slightly different lengths, but we've got 5 and 12. AD, what do I write AB? AD is going to be the square root of 12 squared plus 5 squared. It's a good old-fashioned Pythagorean triple. I don't even know why I'm typing this in. I know the answer's 13, but whatever. Just to be sure. To be sure. To be sure squared, some people might say. Yeah, it's going to be 13, isn't it? So, right, we've got this triangle now. And what do we know about it? We know this. We know ADB. So the three sides of that triangle I've just highlighted are AD and B. We know BD from our first step would be root 250. And we also know that AD is 13. And we know this angle here is 30 degrees. And the question is, what is length AB to 1 decimal place? I shall call this length X. Well, I've got I've got 2 lengths and an angle in between. I want to know the opposite side. This looks like a classic cosine rule question. So using the cosine rule, again, this is on the formula sheet, but the formula I will remind you is a squared equals b squared plus c squared minus 2bc cos a. So a in this case, I always say like the angle is a. That's how cosine works. So if that's big A, that's little a. B and C doesn't really matter which is which. Don't be confused by the fact that some of these vertices have already been labelled A, B, and D. When you use cosine rule, you get to assign your own A, B, and C depending on which side you prefer or are working out. So this is a totally different aspect. Notice how I deliberately chose that to be B, although the opposite angle wouldn't be A. You know what I mean? Doesn't matter. Okay? So A squared in this case would be X squared equals B squared, which is root 250 squared. Again, see, this is why I didn't want to simplify the third, because the roots kind of cancel out. C squared would be 13 squared minus 2 times root 250 times, this bit's 9 over root 13 cos of 30. So yeah, a bit of calculator malarkey now. So 2 times I'm getting x squared is 62.98033. So x is the square root of that. There is more, but 7. How does it went around? It's in one decimal place. 7.9 to 1D, please. Be right, please. I made too many mistakes today. Oh, don't know if I can endure another one. Yep, it's saying here answers between the range of 7.9 to 7.95. So we are good. Great work. Go right, number 19, circle theorems. So we've got a tangent, we've got center, we've got all sorts going on, and the question is asking us to find the angle OAC, which is this angle right here. So let's find it. Okay, and write any theorems we might have used. So let's kick things off. There's two ways you can do. Okay. Right. So I know that a tangent and a radius meter 90 degrees. So that angle there, we'll call it CBO. Angle CBO is 90 take away 74, i.e. 16 degrees. And the reason is a radius and tangent meet at 90 degrees. Right, so we'll start by highlighting that as 16 degrees, beg your pardon. Cool. Next up, I know that this angle here will be half of 96. So let's continue by saying angle ACB equals 96 divided by 2, which, leaving nothing to chance, I'm going to do some more calculate. 96 divided by 2 is 48 degrees. And my reason is the angle at center is twice the angle at circumference. I know I'm writing off the page, but this is just a walkthrough. Okay, so we've got 48 now. Now, you are allowed, don't feel like you have to use circle theorems here. You are allowed to use legitimate reasons. I know it says only circle theorems, but write all reasons anyway. There's no harm in saying angles at a point. So we'll say that the angle AOB is going to be that 360 take away 96, which will be 264. And my reason is angles at a point add to 360 degrees. As silly as this sounds, and despite me using 360 in my working, in your reason you should always say they add to 360. Even though that's obvious from your working, they're really fussy when it comes to explaining your reasoning. Okay, so wrapping things up, to work angles CAO out, or OAC even. So let's write this out. OAC. We've got a quadrilateral, haven't we? We've got a arrowhead, or some people like to call it a delta. Not that you needed to know that in this particular question, but to work that angle out, we'll do, I don't know why I wrote 360 up there. It should actually be 264, right? So it's going to be 360, the whole angles in a quadrilateral. Take away your 48, take away your 16, take away your 264. And I'll write the reason in a mo. And I'm getting 32 degrees. And my reason is angles in a quadrilateral add to 360 degrees, right? So 32 degrees my final answer. I'm just loading up the answers now. Is that right? Please be right, because I don't want to go with the answers. 32 is bang on. Now, there are other ways to get that, but obviously we'll stick to the one I showed. So next time, number 20. Right, 2 to the power y. All of these numbers we can write as powers of 2, hopefully. So 72, that's the same as... now, this is not a power of 2 in its entirety, but it's going to be 3 lots fact. I mean, let's just do prime factorization. Right, it's going to be 2 times 36. 6 and 6. So 2, 3, 2, 3. Okay. So let's just write it as 2 cubed times 3 squared. Because it is. Okay, that happens. 2 times 2 times 2 times 2. Yeah, no harm doing that. Now, this bit here, be a bit careful of this, right? So you should remember that this 8 is just 2 cubed. And we also know that if you're square rooting it, it will be 2 to the half. And all of that is being raised to the power of 6x minus 2. So in essence, we're timesing 3 things together. If I write this down here, you're doing 2 cubed times a half times this bracket here. Now, the smart way to multiply this out is leave the 3 last and expand the bracket with a half, right? Because, half of 6x would be 3x and half of negative 2 was minus 1. So when it comes to multiplying by 3, it'll be 2 to the 9x minus 3. Okay, that's the smart way to do it. There are other ways, but I think you will eventually, no matter how you do it, really, it's, you got to get that. So it doesn't really matter in the order in which you do it. Obviously, the other order might involve fractions and make it the tiniest bit harder. But if you're doing it correctly, you are getting that. So that's the numerator dealt with for now. Let's do the 9 quickly, which is simply 3 times 3. I'll do this in purple again. Now, notice how this cancels out with the 3 squared above. That's handy. And this 4 to the power of... think of 4 as 2 squared. And then you obviously expand it to 7 minus 3x. So if you times these out, and yes, use brackets, you'll get 2 to the 14 minus 6x, right? So this will be 2 to the 14 minus 6x. Okay, so just a few reminders now. We'll deal with the numerator first. I'll do this in red. But look, when you're multiplying powers of 2, you add them, don't you? So the numerator will be 3 plus 9x minus 3, which very conveniently, the 3 and minus 3 cancel out nicely, hence leaving you only with the 9x. And the denominator, it means we're going to have to subtract by this. Now, be really, really cautious for this final step. So it's 2, we'll have 9x on the top, but we want to take away all of this. So use brackets, because a lot of you won't, and you'll mess up when it comes to subtracting negative 6. So the answer will be 15x, because obviously you're taking away minus 6. So taking away negative 6 is the same as adding 6x, and then minus 14. So the answer, y, if you will, so we're saying that that's equal to 2 to the y, so y has to be this. It's going to be 15x minus 14. Please be right, otherwise I'll be upset. Not that I think I am. Perfect. Right, so that's 15x minus 14 is the correct answer there. Love to see that. Okay, so lastly, circle C has a center 3, 1. So 3, 1. Here's a quick sketch. So if you imagine, here's the center, and it happens at 3, 1. Roughly, this is not a great drawing. L is the tangent to C at point A, the outline B. Okay. The point A has coordinates 8, 3. 8, 3 would be roughly there. Again, this is not accurate, 8, 3. So we'll call this point A. And the line L crosses B. So it's got a tangent, and it's going to cross at B. Basically, work out the area of the triangle. All right, so we're going to need to know a few things. The important thing to work out is what is the x coordinate B. So let's work out the gradient here. So the gradient, that green line I've just drawn, the gradient m is the difference in y coordinates. So I'll do y1 minus y2. So it'll be 3 take away 1 divided by x1 minus x2, which will be the same. And we've got to take them away in the same order. So if you choose 3 first, which I did, I will start by saying 8 take away 3. So the gradient would be, 2 on the numerator and on the bottom would be 5. Now, I will highlight this in blue, but the gradient of this blue line will be the negative reciprocal of this, right? So the the value of m here, I'll call this the perpendicular line, will be minus 5 over 2. And you can obtain that by doing 1 divided minus 1 over 2/5, which is simply that. Okay, so this blue line has equation y equals minus 5 2x plus c. Let's work out the value of c by substituting in these two coordinates here. So when y is 3, x would be 8. So what's c, you ask? Well, solving this would give me 3 is minus, well, 8 over 4 is 2, minus 20 plus c. c is 23. So the line, equation of a straight line, I'll continue my working over here because of the space. Just making sure I've not made any silly mistakes. No, it's y equals minus 5 over 2x plus 23. Now the question is, where does it cross where is this point? I'll highlight this in yellow. Where is that? Right, now you know it crosses the x-axis when the y-coordinate 0. So we're going to substitute my y-coordinate 0 because obviously that's where it crosses the x-axis. And doing that, you get this 5 over 2x plus 23. Let's solve that quickly. You're going to get 5x equals 46. So I've done some steps in my head. I want to rush this along. So x is 46 over 5. So it's going to be 9.2 is my x coordinate, right? 9.2. Okay, so this question, if I think about all three lines here, and I will do them in the same color as in my little rough sketch. A to C, remember, was in green. We had this red line, which is the x-axis, and we had that blue line, which I just drew now. So remember, this point A had coordinates 8, 3, meaning the height was 3, right? It's my y-coordinate. My x-coordinate, if we compare, we said that this was 3, 1, this was C, and on the right we had 9 over 2. Hang on a moment. It's just struck me. Right, yeah, forget this. This has nothing to do with C. I'm just reading the question again. Thankfully, because that would have been a slightly trickier question, but we're good to go. This question is actually about triangle OAC. So O being the origin, A being there, and C obviously being that. AB, my bad. So obviously O is a coordinate 0, 0. A we said already, and C is 0. Sorry, 9.20. So this triangle has a width of 9.2, has a height of 3. This should be fairly straightforward then. So the area of the triangle, which is a half of 3 times 9.2, should be 69 over 5, or as a decimal, 13.8 units squared. Let me just double check my mark scheme. I'm hoping this is right because I don't really want to do it again. Yeah, these early mistakes have kind of made me second guess everything. And would you believe it is the right answer? So we finished strong with a bit of a hiccup in the middle. So apologies for the early mistakes. But again, this is live. I try not to sort of research it because, you know, I want to show you that just like you, we all make mistakes. The important thing is that when you show your work in, those mistakes are minimized, yeah? So that's where you sort of, you know, on a worst day, you'll only probably drop to a grade 8 if if you're getting most of it right. And obviously we all strive for the 9. So hopefully you did really, really well on this paper. Do hang around for the answers, and I'll see you on the next vid. Right, here's a mark scheme. So I'll try and pause for a few seconds. I'll try not to talk. I might add bits and bobs if I think that the mark scheme's not clear. think with 9b here, best way to mark 9b is by just sort of rewinding back to my graph. Yeah. Okay. Yeah, if you've seen the video, you would have seen me embarrass myself on question number 10 for not substituting in R cubed, which was very annoying. Yeah, and number 12, I made another mess up. Yeah, not good. But mistakes happen. Again, with 15C, I know I showed you the trick about typing in answers. Looking at this, actually, that may have been bad advice. So maybe save the answers as a way of checking your work. Here, they want you to write the answer to every iteration. So I might have been a bit cheeky with how I showed you how to do this. Just have a look at how they will look in the mark scheme. I still think my mark would get full marks, but my method would get full marks. But again, maybe my working could have been better here if I was being very, very critical of myself. With circle theorem questions, a little bit of guidance when you're giving reasons. The words that are underlined here, you have to use, right? So if the examiner does not see the word tangent, for example, and radius or diameter, you can use either. You won't get the mark for that reason. Yeah. So be really, really careful there. Obviously, there's different ways to write the sentence, but the key words for everybody will be the same. Obviously, instead of twice, you can say half. So don't panic too much about that. But obviously, the key words are the underlined words. So be really, really careful there. Okay, I think we're sort of on the last couple of questions now. Yeah, I can imagine lots of people may have done 20 differently to how I approached it, as the mark scheme indicates. So don't panic if you got the right answer in a different way. Yeah. Again, with this one, you don't need a sketch, but sketches do help you visualize what you need to do. So I always, encourage them if you are confident with sketching. If you don't, and you're sort of good at the abstract side of sort of straight line graphs and triangles, all good. More power to you. But yeah, another successful video. What did you like? What did you not like?